this word, do you know, have you seen this? Raise your hand if you've seen this word before, ever. Okay. Can you pronounce it? Precipitate. Yeah. Precipitate. A precipitate is something you get in a solution. So here, let's draw a little beaker. We have a solution in it, and the solution is nice and clear. Okay? When we say something is a solution, by definition, it is clear because everything is dissolved in it. All of the solid particles are suspended sort of permanently, so it doesn't look like it's got any chunks or anything else. That's a solution. If we add something to that solution and all of a sudden you start to see chunks or it gets cloudy, what that means is you have formed a precipitate. Something has come out of the solution. Now, when we start to talk about chemical reactions in 2 chapters, what you're going to find is that the formation of a precipitate is evidence that a reaction occurred. Okay? And that's really important. I am absolutely confident we're going to get to the behavior of ions in solutions, and we're going to talk a lot about formation of precipitates. We're going to be able to predict by that point whether or not we will form a precipitate based on solubility guidelines. But that's an important thing to know, and I don't think you knew that going in, that if the solution goes cloudy or suddenly you get chunks in it, that means you formed a precipitate, and that means you had a reaction occur. So, looking at your data table for this lab, what I want you to do is just sort of lightly circle every place where you got a precipitate. So with sodium fluoride, when you added calcium nitrate, that's the CaNO3 2 times, when you added calcium nitrate to sodium fluoride, did you get a reaction? Gesundheit. Yeah. It should have gone sort of white. Should have gotten kind of white chunks, or it got cloudy. Is that what you saw? And if you didn't see that, don't change your data. But you should have seen a white precipitate form. So let's just run through what this looks like. And we have not covered bonding or compounds or reactions. So this is all sort of foreshadowing what we're going to do in a little bit. But when we add sodium fluoride and calcium nitrate, which apparently I can't even write this morning, those are the reactants, or potential reactants. And they undergo what's called a double replacement reaction, so they basically swap dance partners. What we end up with, potentially, is sodium nitrate, and this is not balanced. This is just a formula equation, and we get calcium fluoride. Calcium fluoride is non-soluble. So what is that precipitate you're seeing? It's the calcium fluoride. When you see a precipitate, what that means is the thing that is precipitating out is something that is not soluble. It's not capable of being dissolved. It's not capable of going into solution. You guys have all, I would bet you my lunch, and I'm very serious about my lunch, that I am, oh, you have no idea. I would bite somebody if I actually didn't have my lunch. So that's why I feel safe betting you my lunch that you have all made a solution. Has anybody here made Kool-Aid? You've made a solution. Congratulations. If you have not made a solution, I will give you homework. You have to go home and make a solution of Kool-Aid. It's a solution of sugar and some dyes and some flavorings. Pretty easy. But this shows that we've had a reaction occur. What are we looking at in this lab? What's the overall objective? To see how reactive the halogens are. Now, unfortunately, we didn't get to do potassium bromide. But we're going to talk a little bit about it anyway, just to give you an idea. Okay, when we add the silver nitrate to sodium fluoride, did you get a change there? I'm going to set this aside. When you Okay, so we didn't have a reaction happen. So sodium fluoride reacted with calcium nitrate, not reacted with silver nitrate. There was no change, hopefully. Did anybody get any data for the next two chunks? You shouldn't have seen any change there. So sodium fluoride is reactive. Where is sodium? You should have get your periodic tables out. Where's fluoride in the halogens? Fluorine, rather. Top or bottom of that group? Top. Okay. So let's move down the group to chlorine. When we took chlorine and we added calcium nitrate, so we had NaCl plus CaNO3 2 times. Those are our reactants. Did you get a precipitate? No. No reaction occurred. So the chloride ion is not going to form an insoluble compound with calcium. Calcium chloride happens to be fairly soluble. Okay, but what about when we, let me set, actually I'll just delete that. Well, I'll do that for now. What about when we did sodium chloride and silver nitrate? What do we get? Do we get a precipitate? Yes, we do. And the precipitate we get there, I told one of you, I know, I have to write these out every year or I can't remember what the precipitates are. It's the silver chloride. So it's the chloride that's reacting with the silver. And we're getting an insoluble compound, so we're getting a precipitate. Now, you didn't get to do potassium bromide, but let's look at what you would have seen had you done potassium bromide. So potassium bromide would have reacted, it would not have reacted with calcium nitrate, but when you mixed it with silver nitrate, you would have formed an insoluble, I'm running out of room here. You would have formed an insoluble compound. You would have gotten a precipitate, which would have been your silver bromide. Again, these are not balanced. These are just formula equations, so I'm not taking the time to balance them. So we have reactivity with calcium nitrate or silver nitrate in all of these cases. The sodium thiosulfate, the big trick there is that it will actually dissolve the silver bromide precipitate. The silver bromide precipitate disappears with the sodium thiosulfate. Okay, last one. Where did you get a reaction with the iodine? So we had, let's see, for this one we had one compound it reacted with. It reacted with the calcium nitrate. With this one, we had one compound it reacted with, the silver nitrate. For this, we had one compound it reacted with, also silver nitrate. What happened with it? So we're moving down the periodic group. Where did your potassium iodide, the Ki, where did that react? So, did you get a reaction with calcium nitrate?
No.
Really? Okay. Oh, yeah. No. No reaction there. Did you get a reaction with silver nitrate? Did you have a color change? Yes. You had a yellow precipitate form, or you should have. So, we have one reaction. You should not, did it change when you added the sodium thiosulfate? Did it dissolve? Good, it shouldn't have. We continue to have a precipitate. We continue to have reactivity. Did you get a reaction with the starch? Yes. So as we move down, we start to see increased reactivity. We start to see something that will react with more substances, that will react a little bit more vigorously usually, that is just generally more reactive. Reactivity increases as you go down groups. That's the whole point of this lab. So, I don't know if that discussion helps you answer a couple of lab questions. I don't remember off the top of my head, but I think there may have been something about precipitates, evidence of a reaction. No? Okay. We'll stop that there. I'll let you look over any questions for a minute or so, and then we'll go back to talking about periodic trends.